Hello, welcome to the channel. So my name is Victor, and in this series, we are going to be looking at resiliency and site security concepts. So for the CompTIA Security Plus exam preparation, if you've gotten to this extent, you've really gone far. We are almost halfway the series for the exam preparation. So in some aspects of the curriculum, you're expected to be able to explain, to differentiate. In some aspect of the curriculum, you should be able to do. In some aspects of the curriculum, you should be able to do one or two tasks or the other to be able to prepare yourself for the certification exam. So don't forget to like, don't forget to subscribe to the channel if you've not done so. And if you have questions, you can drop that in the comment section. If you also need a discount on your certification exams, you can reach out to us to get a coupon. Okay, let's look at the objectives of this particular module. So this is lesson 7. First, in the first part, let's look at asset management. So what's an asset? In cybersecurity, we normally say digital assets. We'll talk about hack value for the attacker. The attacker is looking at anything that is going to be of value to him. And for cybersecurity analysts, we're also looking at anything that is of value. And it mustn't be something physical. It might not be a server. It might not be a system. It can be anything digital. It can be intellectual property. It can be digital assets. It can be files. It can be content. It can be anything of value, right? So cyber asset tracking is very IC-centric. So because we want to look at who owns, who is going to be assigned this particular asset, this particular item of value. Then in asset tracking, we're also going to be looking at asset tracking and monitoring. How do we do manual inventory? Most systems, most enterprises, they're going to label their systems. They're going to say, okay, this is PC001, PC002. You could do a manual inventory, especially if it's a physical asset. You also have network scanning if you use a tool like Nmap or use any topology-based tool that can map out your network for you. It can give you logical addressing in the sense that you could know the IP address, you could know the MAC address of each of those items. So this is the way to be able to help you track your different assets. You can also decide to use an asset management software depending on what vendor you want to use. We also talk about configuration management database. So you could have a system where you archive all of the different configurations for your different assets. If you have a PC, if you have servers, if you have cameras, if you have firewalls, everything that you have, you want to have a database system where you're going to actually manage all of the configuration and the setup for these items. You can also have mobile device management. So in mobile device management, you typically have a software that you're going to install on all of the different hardwares or devices that you have. For most companies, they could use proprietary softwares or they could use third-party vendor softwares where you install all of the, let's say you are a company that have remote workers or you have field workers, you're going to get them phones, maybe you get them tablets, maybe you get them PCs. So how do you monitor? How do you tell what they are doing at which particular point in time? How are you going to be able to erase a device? Let's say you have field workers for an agro tech company, and these field guys, they go to the field, they collect data, they send to the server, and it's been analyzed in the office. So how do you manage those mobile tablets or phones? So you can use the mobile device management software. Then we'll talk about cloud asset discovery. So in cloud asset discovery, you're going to say all of the digital assets you have over the internet on the cloud. How do you monitor them? How do you archive them? And how do you have a proper inventory for them? Now, asset protection concept. So what are the concepts and items or you need to understand in terms of protecting these assets? So the normal thing is, first, you want to identify and prioritize assets based on sensitivity and impact. So this is where we start talking about PIIs, personal identifiable information. So those PIIs are very critical. PII are very sensitive information. Things like bank account number, social security number, bank verification numbers. All of this information are very, very critical, very, very sensitive, right? So in terms of order in priority, you want to make sure that you identify those and you actually protect them very well, because aside from being sensitive, they can have a great impact if that kind of data has been stolen or data has been lost. Then you want to use standard naming convention. You want to do things like, let's say the name of the company is SOUTECH or CLACACHI Technology Limited, say CTL. So you want to say CTL Web 001, CTL Cloud 001, CTL PC 002, CTL. Most companies, we have their different naming conventions. But the thing you want to make sure is very standardized so that anybody can actually know what's happening, where you stopped in your naming convention, and where I'm going to continue if I'm going to add to this particular asset. Then in configuration management, we want to have a system where for all of the configuration, have a great deal to do with change control and change management, because in change control and change management, it goes hand in hand with configuration management. So they are different, but they work hand in hand. So here in configuration management, you are saying all of the configurations for all of the assets you have. Assets here we mean cameras, devices, phones, tablets, printers. They will have the different configurations. So how do you manage them? How do you make sure that you archive them, you document them? And if somebody, because it plays a good role, it plays a good a positive impact in helping persons that are going to come later on to like manage those things. And that's where change management comes in and change control. Because in change management and change control, you're saying, if this guy leaves, when somebody else comes in, how does he understand, okay, this is what I have, this is the label, this is the configuration, I want to change this, I want to change that. And in your change control and change management, you want to make sure that most of those things pass through a board. Most of those things pass through like a team lead, persons that are going to go through things before you now perform those change. So these ways, you can actually protect your assets. So identifying and prioritizing assets based on sensitivity and impact, use standard naming convention, do configuration management, make sure that you have a proper change control and change management. This concept is a very important concept in project management. You could, I think you have that under the monitoring and control knowledge area in the PMI standard of project management. You can check the channel. I have a very complete playlist on project management by PMI, right? Okay, so when it comes to data backups, we're talking about digital assets here, and backup comes very, very handy, because here we're looking at resilience, we're looking at business continuity, we're looking at the situation whereby if we have an attack, we can get back on track. So what's going to help us to be able to achieve that is data backups. And data backups for small companies, you could do very simple backups. Your simple backups can just be you having flash drives, having pen drives, having hard disks, having CDs, having DVDs, backups, tape drives for very, very small enterprises. But when it comes to enterprise data protection strategy, you can be using an incremental backup. You can be using a cloud system to backup. You can use S3 for AWS services. You can use the one from Azure. You could use GCP. You could use any system cloud-based that can be able to help you store terabytes and terabytes and terabytes of data, right? You can even use a cloud on-site, on-premise, cloud-based system to like do continuous backup from time to time. You could use, for developers, for instance, they use GitHub, GitLab, different systems that will help you channel the code base you have in your development environment to like a staging server before you push it to your production server. So you want to make sure that you are planning backups depending on whether it's for a small enterprise or a large-scale enterprise. And what backups do is that they ensure availability of your data, And also for integrity. Integrity here was saying that people cannot change, people cannot pilfer, people cannot adapt, people cannot tamper with the data, right? So that's what data backup do for you. So even if you have a change, if you have an attack, or if you have a malware that have changed some items, you have to rely on your backup. So it's the backup that gives you a means to like get back on track. So backups are very, very, very important. Like sometime a few months ago, we had a website that had some issues. And one of the best solutions is just look at your backup and wipe out whatever you have that is remaining or pending, and you restore from backup. Same thing happens from network configurations, website backups, cloud backups, file backups, system pieces. Even some companies do entire system backup. So these are strategies that are going to make sure that you are resilient, that you have business continuity. And there's some critical capabilities for enterprise backup solutions. They typically include either you doing physical, virtual, or cloud, or you doing data duplication or compression to optimize storage space. So at times you might want to say, okay, you want to actually not just send to your storage means the same way you have the data. You want to do some kind of duplication, or you want to compress the data before you send it to the cloud. At times you have instant recovery and replication for quick failover. So failover is, okay, what are you going to fall back to when something happens? Ransomware protection, I talked about this. Granular restore options for individual files. Even most operating systems have this feature where you do something like system restore, and it gives you opportunity to be able to back up your files, your folders, and maybe some applications. Then you want to have a very robust reporting and monitoring system. Then you have integration with virtualization platforms, cloud providers, and storage systems, encryption to protect copies of sensitive data stored in backup set. So you don't just want to back up and drop things in the hard disks or in the cloud servers. AWS, GCP, Azure, cloud platforms, OneDrive, different platforms, they have a way you can actually also using either a server encrypted key or a personal encryption key to like password and lock up whatever you have. Okay, so you have advanced data protection. So we have what we call snapshot. So a snapshot is just basically a screenshot or a mirror of what you have currently. So if you have a phone and you take a snapshot of that phone, you're just taking an image of that phone, exactly all of the configuration, the files, the everything. So you can also have VM snapshot, you could have file system snapshot, you can also have SAN snapshot. SAN is a storage area network. So your storage system, you can also have a snapshot for it. And that's going to help you get back on track. But these are advanced data protection techniques. They also have replication and journaling. We have database mirroring. We have SAN replication and VM replication. All of these are means through which you can make sure that you have another copy of your IT infrastructure, your database, your files, your VMs. You want to make sure that you have a second copy. Now, aside making sure that you have a second copy of your systems, another thing is, what about you trying to say you want to dispose of an asset like a hard disk, or you want to clean up, you want to sanitize, or you want to destroy, or you want to certify. Now, for asset disposal, some of the considerations are going to be that you don't want people to pick up these hard disks and get to inspect it, because most of the times for most hard disks, whether it is Seagate, whether it's Toshiba, whether it's SanDisk, no matter the vendor, the way hard disks are built, whether they are SSD, whether they are HDD drives, even if you format using very, very good recovery systems and disks or recovery tools, you can actually still get files that have been inherent, that have been in that hard disk before then. So it's a good practice to either shred or degauss. That's one way you can actually destroy that particular hard disk. Because if you have very sensitive information in that system or that hard disk or those disks, it can fall into the wrong hands. Here we looked at asset tracking, asset protection changes, data backup, advanced data protection, secure data classification. For your exam, you're looking at being able to differentiate and understand what solution will be best for whatever kind of scenario. Okay, for lab activities, you can look at implement backups, perform drive sanitization. And one way you can also do drive sanitization is to do defragmentation, is to do cleanup. So that way you could make the drives better efficient. You can also do backups. You could save to the cloud, or you save to on-premise physical system. Now let's look at redundancy strategies. So in redundancy strategies, what we are after is saying, how do we make sure that we don't just have one point of failure, right? How do we make sure that we can resume activities immediately there's a disaster, immediately there's a disruption, immediately there's a crisis? And that's the concept of business continuity. Business continuity is a very, very crucial aspect of cybersecurity. So we're looking at continuity of operation. So ensuring that an organization can maintain or quickly resume its critical function. Now, the key word there is critical function. I remember there was a time we have a site, it's been hacked. The client got to us and said, okay, we have a situation. We started trying to make sure that critical functions are restored. Example is to make sure that you have phone contacts people can reach out to, you have some of the basic business processes. And that's one of the reasons why businesses move to the cloud. At times you hear this concept of e-business, which is called electronic business. Electronic business is just simply, you have a business that is offline, it does advertising, it does storage, it does phone calls to be able to meet up with clients, it does orders online, it does orders, physical orders, it does logistics, transportation. How do you move all of these things online? So it then means that if you want to do e-business, you have to automate all of the physical business processes. Now, when these things are online, and something happens, there's a disruption, there's a disaster, there's a crisis, there's a hack, these processes get disrupted. It then means that people cannot reach the business, people cannot call the business, people don't have the information, people cannot fill a form, people cannot register, people cannot log in. And one of the things you want to do is to make sure that when these kind of things happen, you want to get back on track. So that's why planning comes very handy, right? Having a very robust plan. At times you can look up and learn more about playbooks. Playbooks are step-by-step guidelines on what to do when whatever happens. If you have a malware, if you have a Trojan, I think I'm going to find time to do a complete playlist on incident response, because this is very related to incident response planning. Because if any incident happens, how do you ensure that you can get back on track? How do you ensure that you could resume operations? So there's a lot of planning. So you have people risks, you have cross-training, because you're going to train team A. Team A, that is operations department, are going to be training technical department. Technical departments are going to be training, let's say, customer representatives. Customer representatives are going to be training, let's say, call agents. So there's going to be a lot of cross-training to make sure that everybody is on track to understand what you're going to do when ABC happens. Even the vendors, at times you might have a particular infrastructure, you can have a particular third-party software that you're using for your enterprise. There is need for that enterprise to train you, and for you to also train your teams to understand what to do when maybe service goes down. It can even be a physical hardware. When something happens, you can no longer serve your clients. What should you do? You should make sure that your team can actually function and get back on track. So you have alternative reporting structures when something goes wrong, changes in workplace capacity. Take, for instance, people retire, people move on with their life, people go for advanced studies, people relocate. So what do? Because that can result to a disruption, rapid hiring, layoffs. So these are factors, these are risks that you need to put together when you're doing your planning. we want to ensure high availability. And high availability means that we want to make sure that things are actually present when it's needed. If I need to download something, if I need to fill a form, if I need to access a particular service, if I need to log into something, if I need to, whatever I need to do, whatever infrastructure that should be available to me, it needs to be available. Now, scalability means we can actually use more services. It can be processor, it can be speed, it can be storage. Elasticity has to do with how do we compress and how do we expand. So at times, like I explained earlier on in the previous module, you can check that in module 6. So how do we make sure, this is a very important concept in cloud computing. How do you make sure that, okay, I need 2 servers, is up and running. I need 10 servers, is up and running. I need 3 servers, is up and running. So that's elasticity. Fault tolerance and redundancy. So in fault tolerance, you're saying how much of pressure can you take? How much of bandwidth influx can you take? Or if there's a fault tolerance, if something happens, how much can you be able to cope with? And in redundancy, you're trying to say, how well can you get back on track? So, and you have different planning in terms of your site resilience. So we'll talk about hot site, warm site, cold site, cloud site. So a hot site is that kind of site in terms of availability that, of course, you're going to spend a lot more, but it's very, very active. You can have, take for instance, you just need 1 terabyte space, but you're providing, let's say, 1 terabyte in 4 places. So that's a very hot. And but for a warm, you're going to be providing only what you need. And if something goes down, you can actually bring back something to be able to provide that service. Whereas cold, it's going to be that you just only have a very minimal system within your enterprise. And it's going to take a longer time to actually get back on track. So most of these things, in planning them, cost is a very, very important factor, or how critical that particular service is for your clients. So that will tell how you should plan your resiliency. And of course, cloud, you could say, okay, I don't want to set up any data center, or I don't want to set up anything on premise. I just want to move everything to the cloud. Then you need to also make sure that you test and see how well you can actually respond to changes. You can do your load testing. You can say, okay, I remember there was a time we set up an application, and one of the things we want to do is to, let's say, send a lot of packets to it, or run some kind of advertising and get a lot of traffic to see how much bandwidth you could actually pick up. You can actually also do a bandwidth calculation. You could calculate how much bandwidth you're going to be needing. You could check your page size. I think there are some bandwidth calculators. I don't want to go off this slide. You could just go to Google and say bandwidth calculator. Once you do bandwidth calculator, it will ask you for some parameters. It's going to ask you for your page size. It's going to ask in terms of kilobytes, how much kilobyte is your page. It's going to ask for how much was the redundancy percent do you need? Do you need 50% redundancy? Do you want 100%? Then it's going to, I think that's all. Then it will ask you how much traffic. So you could say, okay, if I'm expecting 20,000 persons on the site, bandwidth most of the times is calculated per month. So it can give you an expected bandwidth in gigabytes that you should be having. So all of these things goes into planning in order to help you plan your site and make sure that you monitor, you validate, and you don't get down. And if anything goes bad, how do you do monitoring? How do you make sure that you get alerts to say, okay, this is working? If you're running AWS systems, you could use simple email services. You could have a Lambda function that is going to throw up and send data to to simple email service, and to SQS, to SQS can now send an information to SES. SES can now send you an email. Depending on the cloud platform you are using, you can actually do monitoring system. Or you could use several monitoring systems, third-party systems, depending on what kind of implementation you're having. whether it's a network, whether it's a cloud application, whether it's a software you are building. You can also even do custom alert systems, right? You could do a custom alert systems whereby you create a script within your enterprise or within your application, and you are saying once traffic gets to a particular point, trigger an email. Maybe you run a cron job that runs every, let's say, 6 hours or every 12 hours or every 3 hours, depending on what your server allows. And that can send you an email, and you know, okay, we need to do this, we need to do that. Because no matter the kind of IT system you set up without alert systems, you are as good as you don't have a security system. It's like saying you set up CCTV cameras for a shopping mall and there's a control room, but nobody's there. It then means when somebody comes in, still, the person is going to go, you cannot take immediate action. So alerts, monitoring systems are very, very important. So in clustering, we're saying if you put your data close to each other, it provides a better latency for you. So in clustering here, we're looking at multiple redundant processing nodes that share data with one another. You could consider virtual IPs. You could look at active-passive or active-active sites, clustering systems. You can also look at application clustering. So you have a diagram that explains some of this concept. You have the clients sending through this IP address. It hits this, it senses this, and it actually distributes it to this clustered web server farm. So this is where you have a cluster system. These are very important concepts in cloud computing. So I will start a cloud computing series later on the channel, sometime this month, like I said, so that we can deal on cloud concepts. We could do the cloud practitioner, the solutions architect series, and later on we could do a DevOps series. So that will help you understand some of these concepts. But for your exam, for your security plus exam, understand the different concepts, be able to explain them, be able to differentiate them, and that's good enough for you to pass your exam. Power is a very important concept when we look at resiliency. If you're going to be resilient, it then means that you want to take power very important. You want to have dual power. You don't want to have single power. You want to have alternative power systems. Imagine a data center without alternative power. So backups, managed power distribution systems, generators, solar systems, wind farms, electricity systems, they're very important. They help you provide redundancy. Redundancy, you're saying that you have alternate. You have alternate solutions. You have alternative. You're not just one failover, one single point of failure. If this goes down, power goes down, you're down. Okay, so diversity and defense in depth. I've talked about this concept earlier on in the previous module. Here you are saying you want to make sure that you have several layers deep into how you secure your system. You want to try to implement on different platforms, platform diversity. You want to use multi-cloud, but it all depends on what works best for your enterprise. Take, for instance, you're not saying I'm using only AWS, right? So multi-cloud means that, okay, we have some of our infrastructure on AWS, we have some on GCP, on Azure, or we integrate in such a way that we could send traffic to this, and if there's something, we can pull it over to the other service provider. That's a multi-cloud system. Vendor diversity. So you have cybersecurity, business resilience, innovation, competition, customization and flexibility, risk management, and compliance. And that's what you get when you use multiple vendors. Deception technologies. So honeypots. What are honeypots? So honeypots, honey-nets, honey files, honey tokens, fake telemetry. They are different ways to do deception techniques. So all you're trying to do is just like saying, okay, I have a Wi-Fi. Then I want to create another Wi-Fi with same name. It can be SOUTECH-1, SOUTECH-2. SOUTECH-1 is the actual Wi-Fi system or server. Then SOUTECH-2, it's like the clone. It's like the honeypot where it's open, people can come in and I can monitor what people are doing. So it's a deception technique that can help you capture hackers. I did a research sometime for a research work that had to do with creating a deception technique for a web application. So this was how it looks like. There was a file that was meant to contain some, let's say, passwords. Then within a web page, you have a comment. Those of us that program, we're going to understand this concept very well. There's a line of code within the website code base that had something like, okay, we have a password stored here on this file. Make sure you delete when we move to production. So what happens is that when a hacker or most advanced users, maybe they want to pilfer, they want to steal information, they want to check around or want to try to see if they can hack, once they come to a web page, one of the first things a hacker is going to do or a competitor is going to do if the intent is to steal information or to understand how things work, is to start looking at the application and try to know how the application was built. Is by investigating and looking at the source code of the application. So you see, when looking at the source code of the application, you're going to stumble upon that comment that leads you to a link that says, okay, passwords are stored here. When you inspect and click on it, you get to a web page. Then on that web page, you are told, okay, click here to access file and whatever. So this is a combination of honeypot, honey files. And once the person click on that, you can tell the person, okay, sorry, this page is not available. But you've already deceived the person. There was a deception that happened, and you lure the person to a particular web page. And some of the things you want to do is just to grab the person's IP address. Like in that research, what I did was to grab IP address, browser details, system specs, configuration, operating system, Chrome browser settings, and all of those kind of stuff. JavaScript, PHP, Python can be able to do that for you. So once those details are grabbed, then you can use it to plan your mitigation strategies, understand your threat actors, who your threat actors are. So these are very awesome deception techniques that you can actually implement so that you can understand who is behind what. So that you don't just do this when the attack has happened. So when the attack has happened, it now becomes digital forensics. On the channel, I have a complete series on digital forensics, so you might want to look that up. You need to also test your resilience. So that's where tabletop exercise comes in. Here you do some playbooks. You say, okay, let's assume we have an attack now. It's just like when you do fire drills, when you want to put up fire drills. That's what you do. You assume, okay, if we have an attack now and it's a malware attack, what are we going to do? You are going to be responsible for this. This team, you're going to be responsible for this. You are going to be responsible for informing our customers. You are going to be responsible for speaking to the vendors that's in charge of that particular software application. You are going to be in charge of making sure that we can restore back our system from backup. You are going to be making sure that, so you do separation of duties. You do enough of simulations, you do parallel processing testing, right? You do robust documentations. All of these things are ways you can actually test your resilience to make sure that if something happens, you can actually come back on track. So here we've looked at continuity of operations. That's making sure that whenever incidents happen, we can get back on track. We've looked at capacity planning, high availability, that's quality of service, clustering, power redundancy, diversity, deception, and testing resilience. Let's look at physical security. Now, you can't talk about assets without talking about physical security. That's why you see a lot of military guys, a lot of men in uniform. They have a very soft spot for cybersecurity because there's a very thin line, or maybe there's an intersection. You have subsect within two fields: physical security and cybersecurity. In physical security, we're trying to protect physical assets. In cybersecurity, we're trying to protect digital assets. But they go hand in hand. Most of the times when you're protecting physical assets in physical security, you have digital assets within the enterprise you have to protect. And at times in cybersecurity, when you're trying to protect digital assets, you have to understand physical security components. That's why at times for students, I tell them, go learn access control systems, go learn CCTV systems, go learn some of these things, understand what is in the DVR, understand different types of camera systems, understand access control, swipe cards, NFC cards, RFC cards. All of these concepts are very key to be able to help you understand how to protect the critical assets you have within. You don't put a data center in the moon. It's going to be in a physical location. And because it's going to be in a physical location, you're going to make sure that the first line of defense to that data center is protected. So that's where site layout, fencing, lighting comes in. So if you have a data center, even if you have a small enterprise and you have some very high worth digital assets within that environment, you need to have barricades, you need to have fencing, you need to have lights, you need to have bollard, you need to have access control system. That's only what is going to guarantee that the digital assets you have is protected. So physical systems, man traps, cable locks, access badges, all of these things will protect your digital assets. CCTV surveillance systems, motion recognition systems, object recognition, drones, unmanned area vehicles. That's what you call UAV. So you want to do some surveillance, all of these things. So to actually have security, you have the cyber security, the technical controls, you also have the administrative controls, you also have the physical controls. So there are different types of alarm types. For your exams, you want to be able to differentiate them. Then you have different sensor types. So in this module, we've looked at access controls, lighting, gateways, security guards and cameras, alarm systems and sensors. And that's all for resiliency and business continuity in the CompTIA Security Plus certification exam prep. So it's been a very long ride. So if you have questions with respect to this module, you could talk about it, you could inbox, you could use the comment section, and I hope you're enjoying this series. I'm going to see you in lesson 7. We just talked about resiliency site security concept. So for exam, I hope you take your notes, you do well. You can watch more than one time, so you could download, you could share to friends that are interested in taking a Security Plus certification or want to be aware about security.